Okay, right. Well, last week we looked at some of the sort of basic ideas about communicating, about knowing your audience, about knowing what you want to say, refining that down to what you need to say, and various other related questions. And today, I want you to start thinking about putting that directly into practice in relation to your the question you're choosing for your assignment, whether it's the enterprise systems one or whether it is the information security and assurance set of questions. And as you know, you're each creating your own infographic poster. And if you haven't already had a look at examples of infographic posters, then I suggest you, when you get down into the labs, spend some time looking at the sort of infographic posters that are around. Search inside Google for infographic posters on the image side, and you will have more versions and types of infographic posters than you can imagine. There are also lots and lots of infographic posters you can download when you sign up to some of the industry types of websites, the ones that send you regular weekly or monthly reports about things that are interesting. They almost always incorporate one or two infographics, and that'll help you understand what it is you've got to deliver in about 2 weeks' time for your assessment. So today is about focusing your ideas. So if you're doing ISA, you're looking at questions in relation to that sort of focus of big data and the Internet of Things, questions of ethics, trust, governance, security, audit, and/or provenance. And by and large, you're going to focus on one of those questions, but you may need to bring in one or two others to kind of give the total picture. But really, if you're going to look at ethics, then you kind of have to link that to the idea of governance. And governance kind of is related to questions relating to doing the right thing in the right way, at the right time, to the right quality, to the right, and you can add lots and lots of little phrases, the right way of doing things, the right attitude, the right ethics, and so on. Because governance ultimately is all about how organizations do the right thing for all of the relevant stakeholders. Whether it's the customers looking after your data, and of course if we go back to what happened a year and a quarter ago, December 2013, when the target company managed to lose something like 70 million sets of identity, or this Christmas, the huge hack into Sony, and the various other hacks which have extracted large amounts of customer data. That's a problem. Sony, over Christmas, had a problem both in terms of their customers not having access to the facilities, but also had an enormous impact in terms of shareholders, because the shareholders were losing value because Sony couldn't do a thing. The whole infrastructure had been effectively destroyed for several weeks. Or it could be customers or suppliers. So there's lots and lots of people are involved, lots and lots of stakeholders are involved in looking at that problem of governance, which really leads across to some of the other ones as well. Security, well, close on 1 billion sets of identity were hacked and stolen during the last 12, 13 months. Somewhere between 800 billion and 1,000 billion. Sorry, 800 million and 1,000 million. An enormous number of thefts of identity. And it's getting bigger and bigger year on year. So security could be a problem in terms of the Internet of Things, in terms of big data in general. If you think about things like, in terms of the Internet of Things, the connected house, the smart house, with all of those clever new things, the Nest controllers for your lighting or whatever else, your smart heating systems, your smart meters, so they're chattering back every 30 minutes or so to your electricity or gas supplier once they get installed. That opens up very interesting questions of security. How many of you saw the article over the weekend or last week where the guy who runs leads the Kaspersky company, you know who they are, the people who make virus scanning and firewall software. Have you come across it, Kaspersky? The guy who owns that, who runs it, Kaspersky himself, was saying, we do not know how to secure all of this infrastructure. We might do in a few years' time, but at the moment we really don't know. And he used exactly the same example as I've been using for the last year and a half. He said, if you want to know what governments are really, truly scared of, go and watch Die Hard 4. How many of you have seen Die Hard 4? You understand what I'm getting at? Some hackers in that film broke into air traffic control systems, they broke into the land traffic control systems, the traffic lights and so on, they broke into utilities and caused astonishing levels of havoc. We've seen one or two little examples of that in the recent past with the problem of the Stuxnet virus. Who's heard of Stuxnet? Would you like to tell us what it's about then, briefly?
Stuxnet is a government, supposedly government-sponsored malware that infects control systems and is designed to take down. Is it raining?
Well, the first instance of Stuxnet was to take out the control systems for the uranium enrichment facilities that the Iranians have got. And it did a good job because it took out the overspeed control so that lots of these little centrifuges oversped and blew themselves apart. And it is believed, but never yet been proven, that Stuxnet was created by government agencies. It's a very, very clever one. Who knows? There's a more recent equivalent, not necessarily with Stuxnet. Nobody knows who the culprits were or how they broke in very clearly. But they managed to get into a steel refinery in Germany, and they effectively destroyed one blast furnace. But either over-temperatured or it didn't behave properly, and it wrecked it completely. So all of these connected things are a big problem if you look at security. You guys who are doing computer forensics are kind of rather interested in some of these topics like audit and provenance, aren't you? Well, you should be anyway. How do I prove that the evidence I've got, that I'm presenting to you, the court, or you, the well, probably mainly the courts, how can I prove that the data I'm presenting is actually the data that was found on this PC, this server, this set of data in this company? Now, it's not too difficult if you can get your sticky hands on the server. You bag it, take it to your secure environment, and then there's a certain protocol you go through to extract images of the hard drive and so on and so on. In principle, relatively easy, and you've been doing things like that over the last year or two. What becomes interesting with big data and the cloud particularly, and this Internet of Things, is I can't actually bag all the controllers or all of the hard drives somewhere in a cloud provider who's storing all the data. Think about if you've got an Android device and you switched on location services and you are tracking yourself and generating thousands of points a day which are stored somewhere in Google. And then the police come along, or somebody comes along and says, right, I want to be able to prove where you were on such and such a day. Well, I can't go onto Google and say, I need to borrow that server, because actually who knows where the data is stored. It's probably spread across the countryside, across the world, and replicated and replicated and replicated as backups. Which one do I take? How do I prove that the data I've got here is actually the real data that was collected on you, the suspect's, mobile phone or smart device? So provenance becomes a really fascinating question. You go in not for criminal audits, but you go in for financial services type of audits. You know, there's a problem inside the company and someone's being accused of fraud, and yeah, it's a server in the company. It's easy. Here it is. I've got it. I can get a disk image. But an awful lot of companies are now going to software as a service type of environment. They don't have their financial accounting system sitting on their own server in their organization. It's software as a service through some cloud provider, and like all cloud providers, they've got sensors around the world. They distribute and mirror and copy the data all over the place. So your audit and provenance problem becomes really fun. How do I know, how can I prove the data which shows that you, not just a suspect, but I can prove in a court that you are a fraudster. I can prove with the data I've got here that yes, you did extract £1 million for your gambling habit. If that data is out there, how do we go about proving what the audit shows? How can I handle the provenance question in a way that guarantees, beyond reasonable doubt, that you are the one who actually did it? So there's some really fun questions when we've got this huge amount of data out there, 80% of which is of uncertain validity. We really don't know which is right, which data is correct, which data is incorrect. Well, we can make a guess, but we don't really know for sure. Or for enterprise systems, again in relation to big data, the Internet of Things and so on. Okay, for businesses, SMEs or even large businesses, what are the opportunities? Now some of you are looking at the project I've set for you, which is location services accuracy or otherwise, and as the Think Near reports every quarter show, the location data that we generate on our little gadgets is of pretty uncertain reliability or validity. Only about 35–40% of the data is accurate to within 100 yards of where you actually are. Somewhere around 12–13% is more than 60 miles in error from those. So if you are a marketeer, and it's marketeers who are the most active users of location services for their organizations, if they send out adverts, hey, you're nearby this shop and there's a discount for you if you show this little code, and they say this is valid in Leicester, and you say, hang on, why are you talking to me about going into Costa at Leicester when I'm actually in Derby? It's not terribly good for the reputation of the organisation. So the question then, opportunities, yes, you can get some target, if you know you've got a really accurate location, yeah, you can drive business into your own organisations. But the challenge is that it's pretty unreliable. So those, you probably want to look at that and that together. You might even want to look at benefits, and there is lots of data around all about the benefits of using the Internet of Things, the IoT, both in terms of location, but in terms of lots and lots and lots of other things that are beginning to pour out of the ether based on what we're doing. Now, there was a conference down in London a couple of days ago, and one of the guys who did a presentation was from Bangor University, a research, PhD researcher doing things to do with location and then visualizing. And he has one of these little gadgets, this life monitor, that sits at a little tag here with a little camera that takes a photo every about 30 seconds with the latitude and longitude, the magnetic direction he's facing when he takes the photo, and he's generating 1,500 photos a day that go onto some website somewhere that he can then use as his memory of where he'd been, what he'd done, and all those sort of things, and who he'd met. That's benefits. Then operations. Well, operations is really about, what do we need to do with our IT systems, our communication systems, so that we are able to reduce the level of challenges, perhaps, meet our governance requirements, our legal requirements and security, for example, try and mitigate against that billion sets of identities being nicked every year now. Other reports coming out of the financial services environment are saying that these risks are going to grow. They are not going to get smaller. So those are the sort of fundamentals of what you need to be thinking about to provide some focus for your little project that each one of you is going to do. So, what you need to think about really is a focus in terms of the sector of your report and your article. Yeah, it could be an SME, it could be something slightly different. It doesn't really have to be SME, but there's more people out there who are interested in your research and your work who are going to be SMEs. There's 4.8 million SMEs, and there's only about 1,000 to 2,000 large organisations bigger than 500 employees. So, think more particularly about SMEs than for the big utility companies or Rolls-Royce, for example.
What's an SME?
Small, medium enterprise. So these are organisations below 500 employees. The medium size are somewhere between 50 and 250. There's about 10, 20,000 of those in the UK at the moment. And the remaining 4.8 million organisations are from 1 to about 50 employees. If you really want to find out exactly what the definition is, there are definitions UK definitions in various government websites that say this is what an SME is in terms of numbers of employees, and in terms of turnover, and in terms of capitalisation. And they're kind of three different ways of looking at them. Think about, are you going to target a particular area of big data and the Internet of Things? Are you going to target a business sector, maybe marketing or maybe sales, engineering? Because there's a lot of activity going on in a lot of organisations to collect huge amounts of data from their customers' installed equipment so they can provide remote support for their customer. And I was at a conference down in Santiago in Chile in, September. And one of the points that was made then was that various organisations, big machine tool organisations, are beginning to change their business model from, we're going to make this big machine that does something for you or produces what you want to produce for your business. So you pay up front £1 million, and then every now and then, when it breaks, you come back to us and we'll send an engineer out and we'll charge you time and materials. What this company based out in Scandinavia was thinking about was, why should we do that? Because actually, that company doesn't really want to own the machines that make widgets. Yes, they sell widgets, but they don't really need that capital investment for £1 million to make the widgets. It'd be much nicer if they could pay a few pence per widget as royalty to the company who makes that big capital machine on the basis of the output, and then say, okay guys, it's your responsibility, Mr. Maker of the machine, to monitor it, find out, predict really when it's going to go wrong, and get your engineer on site quickly with the right bits and pieces to fix the machine. And it's all your responsibility. We just pay you a small fee per widget we make. So that takes the widget making machine away from being a capital expense that they have to fund and then pay interest on the funding and so on. Takes away from that to being a revenue expenditure of a few pence perhaps per widget that's manufactured as part of the cost of manufacture. And if you think about the aerospace industry, Rolls-Royce across the way, General Electric, Pratt & Whitney in the States, who make big jet engines for aircraft, they are selling, as in transferring ownership of the jet engines, which is what they used to do, to first of all, the airframe manufacturer, Boeing or Airbus, who then sold the whole aircraft plus engines to the airline, who then had a huge capital expenditure up front. What they're now doing, and they've been doing for the best part of 10 years, is saying, okay, here's this 10, 12 million pound thing called a jet engine, which hangs off the wings of your aircraft, and for every hour that you use it, we will charge you a fee. So that over the 30,000 hours between major overhauls, which many of these engines now have, which will give you 30,000 times 6, you know, 1.5 to maybe 16 million miles of flying, you pay us a rate per hour plus an extra fee per takeoff and landing cycle, and no, they build that up, they collect thousands of parameters a second off the each engine, beam them back to Derby here, where they have a big data center, and they are looking at the data pouring out of the sky as the aircraft actually fly, with the analytics going on, say, that engine on that flight, British Airways flight to Washington DC, we've just seen some signs, and it's halfway over the Atlantic, and we can say it's going to need, something's gone slightly wrong, we need to get one of our engineers, or one of your engineers, to go look at it, and this is what you need to fix. Or they can even say, it's now getting so difficult, you need to schedule a replacement plane for the return journey, because we're not going to be able to fly that plane back to the UK. They can do all this in real time. And in the 1980s, I was actually part of the team who was involved in that data gathering and analysis machinery. Only it's got lots and lots more powerful since then. And more airlines are buying what we call power by the hour. Because it means they don't pay say for a 787, the capital cost up front, if you buy those two engines, is probably going to be close on 20, 30 million sterling. Right at the front. But if you can pay a few hundred or a few $1,000s an hour for flying it, it's a cost of sales. It's not a capital up front. So, think about which area you want to focus on, what part of big data, what part of Internet of Things, maybe for big organizations or maybe for SMEs. Now, big data classically is defined by 3 V's of volume, velocity, and variety. Gigantic amounts of data, the volume, velocity pouring out of the sky at unbelievable rates of streaming data, and the variety is multiple data sets, different formats, different structures of data. If we think about using social media, it's not even structured. Think about tweets on Twitter. When people tweet, people don't even follow the normal grammatical, syntactical, and vocabulary spelling approaches to the English language or whichever language they're using. They break all of the conventions, so you can't even rely on syntax and grammar to impose some structure on the data in tweets. So you've got problems of variety, and then I'll show you in a little bit another 8 or 9 words beginning with V that kind of give you some worries about the nature of big data and how you can and can't be confident in your analysis. So, first of all, target sector, area of big data and the Internet of Things, and then narrow that down to what we talked about last week, which is topic. What is the real tiny focus of that article that we're going to write, or each going to write? What's your aim? Is it just to inform, or is it to persuade? I mean, you're really kind of thinking about in terms of organisations out there who might want to read your e-articles when we publish it as a book, an e-book. Why would they want to read it if it's just information? Think about it in terms of, here's something that I have researched, you guys, which is really, really interesting, had big impact out there, and it's something you guys who are reading this article didn't even know you didn't know. If you go back to Dick Cheney's sort of sequence of things we know, things we don't know, and so on and so forth. The really, really difficult one are the things we didn't know, because they're going to bite us badly, or potentially they will. So those are going to be the most fun, most interesting, most impactful types of article. So that's the aim. What do I want to do with my article? What do I want to do out there with the readers? Now, the poster, the infographic poster, is all about how do I persuade the reader that this is really important and it's something they didn't know, but which is really critically important to them. You've got to get some data, some numbers, some statistics that you then present in a powerful way on that poster you're going to create, which will kind of grab their attention so that in, notionally, another 6-8 weeks, they will want to read that article that's associated and paired with your poster. You want to drive them into your report. Drive them, or capture them perhaps, to read your report. So those are the sort of questions you will be thinking about the rest of today downstairs, and one or two things up here as well perhaps. Now you might want to think about it in terms of these sort of areas. People who produce the data or capturing it, it might be the people who need to use it, or it might be, particularly if you're thinking about SME environment, the consultants who help SMEs use all of this amazing IT that's available. Because the consultants need to be brought up to speed with some of the interesting opportunities, the challenges, the dangers, security impact, the governance impact, etc., etc., etc. So you could target it at one of those sectors. You might even want to target it at us, the general public. Do we really want to capture all of that and make available to everybody all of that data about where I've been every minute of the day that Google is particularly capable of doing through the Android devices? Not quite so simple, not quite so set up in such a way with the Apple ecosystem. And then you might think, again, am I going into retail? Am I going to financial services? You could add all sorts of other sectors. Transport's going to be a really interesting one to think about as we get more and more smarter and smarter cars with more and more sensors, all on one data bus, connected by Wi-Fi or 4G or 3G or whatever, back to base, which might be the insurance companies, it might be the manufacturers. Things like updating the software over the internet, thinking of all of the possible security problems. Or you might want to focus into, some of you, forensic services in terms of that audit and provenance side. Where is this stuff? All this big data sculling around, which we're using for executive decision making, but yet is also amenable to fraud. In terms of trust, we can go back to the analytics that produce the numbers, the statistics, and the way that then people present that data in ways that perhaps are not ethical. So there's lots and lots of opportunities there in the SME or the big environment. Here's a list of words beginning with V, the original three that define, to some extent, big data. And yet, of course, the volume one, if you looked at the original definition, volume, more data than we currently know how to handle easily, well, that changes year by year. It's not long ago that people were worried about petabytes of data, but now that's becoming kind of trivial. Petabytes is 10 to the 15 bits of data, or bytes of data. But on Friday, on Tuesday, down at the conference in London I was at with several others from here, the next one is 1,000 times larger, Exascale, 10 to the 18. We're talking gigantic amounts of data. which also pose huge problems for processing because we now need potentially 1,000 times more compute power, 1,000 times more storage. And we're beginning to run out of electricity to actually drive these things. We're having to change, or beginning to think about changing the technologies even. We can't rely on Moore's law any longer to get more and more compute power out of our chips. Have to change the technologies in some fashion or other. The various reasons, I'll put up very shortly a link to a presentation or two that I've given which actually goes through each of these different V words. But variability is the fact that data is not actually, we are not really stable in the data we publish. We may tweet positively one day about something and then change our stance tomorrow and tweet negatively about something. IBM invented the V for value a few years ago, pointing out that if we are in business, it's absolutely crucial that we think about the value of the data that we've got, but also, yes, we can do lots and lots of analytics, but does the result of that analytics lead us to being capable of generating additional value for the organization? What sort of value are we actually creating? Is it pound notes, better profitability? Or is it value for our customers, the users of our systems? And you think about all those apps on your smart devices. Why are we using them? Because we get value in some way which is not monetary most of the time, but allows us to do things we couldn't do before. We can do things like, we can look up on a map whether we read a novel and find exactly where they are taking us through in the story. And I did that with a story a year or so back, which was set in Florence, in Italy. And you could go through, when they were having a chase through the park, you could actually find out where they entered. As they moved through, you could actually get down into street view mode to see what that street would have looked like, or that big building. And so that's a sort of different sort of value. Does that lead to extra value in pound notes terms? Who knows? We've talked about veracity fairly regularly, about can we trust it, and John Easton has obviously said, as I've mentioned before, has said so many times, or I've referred to it so many times, 80% of all the big data out there is of uncertain veracity. We don't know which is correct and which is incorrect. It's not saying 80% is wrong. No, far from it. Much of it is accurate within some limits. But we don't know which bits of data are correct, which bits are incorrect individually. Maybe there are algorithms we can link them together and see, and that kind of might give us an idea. And if you use something like NeoTrace to track from where you are to the website that you're browsing, where are all of the servers, you can do some really interesting things. And yet even that shows up every now and then. Here is a switch, not a server, switch. Here's a switch that probably is up there, but it's shown 10,000 miles away sometimes. And so you see really bizarre traces in a lot of this IP-based tracing of location. The databases are incorrect. Often, many times, the databases don't reflect anything other than the location of the owner of that block of IP addresses. Validity, again, is related to veracity. Then you've got volatility. How long does it last? How long does its truthfulness last? Sometimes it'll last for quite a long time and be valid for a long, 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 long time. You know, data about your phone number. If you are a telecoms company, the linkage between my name and the phone number and the various other codes that sit inside here are going to stay with me for 18 months, 24 months, as long as I have that particular device. If I roll over the contract, the phone number will stay the same, linked to me, but all the other funny things that relate to the insides of this, they will change. But other things are going to change much, much more rapidly. Verbosity is all to do with some of the problems of text analytics and the fact that human beings understand the meaning of words in really quite bizarre contexts. But we can normally understand each other quite well. We also, because in terms of voice and our intonation and our facial movements, our body language, we can detect irony extremely effectively. But when you just turn it into text, which has none of the body language, none of the intonation relating to it, it's very difficult to be sure whether that's a positive statement, as written, or whether the person writing it was being ironical and saying, yeah, great, meaning that's absolute rubbish. But we can understand that and detect it. We understand semantics, the meaning of words, in context very, very well. But getting IT, computer systems, to understand the meaning of words is very, very, very difficult. We really don't understand how to do it properly yet. So it makes analysing text and extracting meaning quite difficult. We can do some clever things in terms of frequencies of words, frequencies of this, that, and the other. But it doesn't necessarily link from there to all of those ones. Lots and lots of issues and problems. Vulnerability comes back to security, the fact we do not know how to harden our systems properly. Even amongst us, I raised a point either last week or the week before about the Wi-Fi transmitters at home. How many of us, I asked, actually have done the solution, which we know today at least guarantees reasonably high security for our home Wi-Fi network, and use passwords for PSK, for WPA greater than 31 characters. Not many of us do that. It's too hard work. We can't be bothered. And yet, anybody coming along sniffing, and many of you forensics guys will know how to do it, where to get the equipment from and so on, how to, even for a Wi-Fi transmitter which has got the SSID broadcasting switched off, you can still sniff and see it eventually and pick up the traffic, and then with that 50 pence and a half an hour on a website somewhere, you can get the passwords to get into that device. So vulnerabilities is kind of interesting. If you're looking at IoT, then the vulnerability of, say, smart cars becomes kind of interesting. And then verification is making sure we know what we're doing and so on. So the question I pose here is, do any of these Vs, which most of the new Vs were brainstormed by your predecessors about this week last year? You might want to think of some more that might be of interest, that drive you to really, really interesting questions. So, let's just see what else there is. So, for the rest of this remaining 15 minutes, first of all, each of you, and you can discuss with each other, what's the title of the project you're each going to undertake. And again, this is where brainstorming together can kind of help add value to what you're doing and get a more focused, more refined sort of approach. Thinking back to last week, what is that specific purpose statement that you are going to use both for your infographic and for your article? Thinking about all of those other questions, what do you want to achieve? I talked a bit about that informative or persuasive bit, and then the really important part for your infographic poster in a fortnight's time, when we spread them out all the way around the wall here, is going to be, what statistics do I need to have that make for a very powerful, attention-grabbing poster that will lead me to be able to produce a spectacularly successful report?